Hello, I'm Professor Rad, and today we're going to talk about factor trees and prime factorization. So let's get started by defining what both of those things are. Well, we'll define factor tree later, but let's start out with prime factorization. So the prime factorization of a number is the form of the number written as the product of its prime factors. Okay, so what does that mean? So that means we're going to be looking for a number to be written out as a bunch of numbers multiplied together, where each of those numbers we're multiplying by is a prime number. A factor tree is often used to find the prime factorization of a number. So that's going to be the technique we use in the next part of this example. But first, let's talk about prime factorizations first, because it's a little bit easier to look at some factorizations or things that are not factorizations and figure out if they're prime factorizations or not. So I've got a few expressions written here, and we want to know if these are prime factorizations or not. So here's what I'm looking for. First, I'm looking for a true equation. So bring my friend here. And let's just check this to make sure it's true. 2 times 2 times 3 times 7 does indeed give me 84. Okay, so I know that this is a true statement. That's good. So I'm going to write down what I'm checking. Is it true? Yes. Okay. Next, is it a factorization? Meaning, is it all multiplication? So I have times, times, and times. Yes. And are all of those numbers prime? So this is why we mentioned our list of 20 prime numbers in the last video. So what I'm going to do to kind of help me do this check throughout is list out the first few primes. The first prime is 2, followed by 3, 5, 7, 11, 13, 17, 19, 23, 29, and that's good enough for now. So these are all of the prime numbers that are less than 30. So we can use that as our check to see if these are all primes. So we have 2, 2, 3, and 7. 2, 3, and 7 are all prime numbers. So since this expression passed our check, this one is a prime factorization. All right, let's take a look at part B. So first, let's see if it's true. 5 times 9 times 13. We get 585, so it's true. Do we have only multiplication? Yes. Are all of the numbers listed prime? We've got a 5, which is there, a 9. Nope. 9 is not prime, and that's because 9 is divisible by 3, right? 3 times 3 gives you 9. So this is not a prime factorization. All right, let's keep on going. So 2 cubed times 11. Let's see if we get 88. So 2 cubed times 11. Cool. So this one is true. Then is it all multiplication? Yes. So this is where prime factorizations or factorizations in general can be a little bit sneaky, because when you have an exponent, remember that exponents mean repeated multiplication. So 2 cubed times 11 means 2 times 2 times 2 times 11. So when we're looking at prime factorizations, we do actually allow exponents. That's okay to have. And then, are all of the factors prime? Well, 2 is the first prime, and 11 is on our list of primes. So yes. So this one is a prime factorization. Okay, let's check part D. Let's see, is it true? 2 times 3 to the 4th? No, it's not true. I get 162. So 162 is not 90. So this is not a prime factorization. Of 90. That one was easy. Okay, let's check this next one. So we have 69 plus 3 is 72. So we at least get a true statement this time. Is it all multiplying? No, we have a plus. So since we have a plus, this is not a prime factorization. All right, cool. So these are some ways that you can check to see if you get a prime factorization. One of the reasons we want to be able to check is because we're going to be finding prime factorizations, and we want to be able to tell if our answers are correct or not. So let's go ahead and make some factor trees to find the prime factorization of a few numbers. Okay, so we're going to find the prime factorization of 585, 90, and 72. I'm going to start out with 585 first. So I'm going to write that here to start out with. And I'm going to grab my calculator. So in order to make a factor tree to find a prime factorization, what we are going to do is we're going to keep dividing factors out of 585. So we're going to keep breaking it down until we can't break anything down anymore. To help me, let's list our primes again at the top, the first few. So we had 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Again, I happen to know these because I work with prime numbers a lot. So the more of the factor trees you make, the easier it will become to remember what these prime numbers are. So I'm going to use my divisibility check that 5 is a factor of 585 because it ends in 5. So what I'm going to do is I'm going to split this off into 2 directions, and I'm going to divide it by 5. And I get 117. If I want to check, 117 times 5 gets me back up to 585. So we're going to make it so you can see what's on the screen of the calculator. And so in order to go down the tree here, making the roots as it were, you divide. And if you want to travel back up, you multiply. Now we're going to look at each one of these. And if we get a prime number, we're going to circle it. So 5 is a prime number, so I'm going to circle it. 117 is too big. I don't know. So let's see if we can break down 117. So I know it doesn't break down by 2 because 2's even. Let's try 3. So the trick for 3 to see if it works is add the numbers, and if 3 goes into that, then 3 goes into the number. So 7, 8, 9. 3 goes into 9, so 3 is going to go into 117. It goes in 39 times. So I'm going to break this up into 3 times 39. Now, 3 is a prime number, so I'm going to circle it. And let's move on to 39. 39 is odd, so that means 2 is not going to work. 9, 10, 11, 12. 3. 3 works because 3 goes into 12. 39 divided by 3 is 13. So we get 3 and 13. And just a reminder what I mean when I say that it works if I get a whole number when I do the dividing. So 3 we already know is a prime number. 13, it's on our list, so that's a prime number. And now notice all of the ends have been circled. There's nothing left to break out. These numbers that we have at the end are the prime factors of 585. And to write the prime factorization, we write as if we multiply them all together. So our answer to part A is going to be 5 times 3 times 3. You do want to list the repeats, times 13. Remember to check if something is a prime factorization. All these numbers should be prime, which they are. It's all multiplied, and it should be true. So let's check. 5 times 3 times 3 times 13. We do. We get 585. All right, so let's go ahead and try and find a prime factorization for 90. I'm going to do this one over here. So this was part A, and now this is part B. Let's do 90. Now, one of the things I like about a number like 90 is it ends in 0. So that means I know 10 goes into it. So let's try. 90 divided by 10 gives us 9. Now, let's look at 10. It's not on my list of primes, so I'm going to break down 10. I got to split that up. What are two numbers that multiply to give me 10? Yeah, 2 and 5. So I can use 2 and 5. I could write 5 times 2. It doesn't matter. Now let's check 2. 2 is on our list of primes, so we circle it. 5. 5 is on our list of primes, so we're going to circle that as well. Now we're not done. We just finished the branch that came off of 10. But see how we have this end here that we haven't touched yet. So 9, is 9 a prime number? Nope. So 9 we can break down. Now 9 is the same as 3 times 3. So I could write that as 3 times 3. And 3 is on my list of prime numbers. So we can circle that. And now I have circled all the ends. So our prime factorization is 2 times 5 times 3 times 3. Let's check that, make sure we've got it right. 2 times 5 times 3 times 3. Did we get 90? Yeah, we did. Okay. Now, one of the really cool things about math that I don't think is talked about enough is that there are often lots of ways of doing something, and you can still arrive at a correct answer. So I'm going to redo part B, but I'm going to do it in a different way. I'm going to do B in a very methodical method so that if you're not very comfortable with those divisibility tricks, if you're like, Professor Ed, it's great that you know that since it ends in a 0, 10 is going to work, but I'm never going to remember that. Don't worry, because there's a method that will always work whether you know those divisibility tricks or not. So here's what we're going to do. So I'm going to split up 90. Now, when you check your factors, you don't want to use 1 because 1 always works, because 1 times anything is the anything. So I'm going to start with 2. 90 divided by 2. That gives me 45. So that means 2 goes into 90 45 times. And I can break up the 90 into 2 and 45. All right, 2 is on my list of primes, so I'm going to circle it. Now I'm going to do the same process with 45. I'm going to try by checking 2. Didn't work. So let's try 3. 3 works. 3 is also on my list of primes. Okay, let's look at 15. 15's not prime, so I'm going to pick up with the last number I checked. So last time I checked 3, I'm going to try 3 here. I get 5. So I know 3 is prime. 5 is also prime. So for my prime factorization of 90, I get 2 times 3 times 3 times 5. Let's see if that's what we got. We had 2 times 5 times 3 times 3. 2 times 3 times 3 times 5. So actually, what's nice about the prime factorization is that all that matters is that you have the right factors, the right numbers that are being multiplied. So both of these have a 2, they both have 2 3s, they both have a 5, and they both have nothing else. So that is correct. So the order that you list your numbers in the prime factorization doesn't matter. You can list them in any order. And in fact, you could even write this using an exponent. Since the factor of 3 happened twice, you could write that as 3 squared instead of having to write 3 twice. It's up to you, or it's up to how the problem wants you to give your answer. But also notice that our work looks very different. So for B, I had this kind of tree. And then when I redid it, I had a different looking tree. And that's okay. Both of these trees work. So let's do 72 using the same method I used here, just to make sure that we have a method that always works. So we're going to do 72. Now I've pushed my prime number list off the page, so I'm going to write it on the side here, just for reference. Okay, and now for part C, let's do 72. So let's try 2. Sweet, 2 works. So I got 36 there. So we have 2 and 36. Now, 2 is my very first prime, so let's circle that. Now, I'm going to try the last number I tried into 36. So I'm going to try 2 again. And it works. I get 18. So we have 2 and 18. 2 is still prime. That's not going to change. And now let's break up 18. Again, I'm going to try by starting with the number I just used. So 18 divided by 2, 9. Sweet. So we've got 2 and 9. All right, so I'm going to try to break up 9 using that same number. 9 divided by 2, didn't work. So I'm going to go to the next number on my list of primes, which is 3, and let's try that. It works, we got 3. So 9 splits into 3 times 3. Since 3 is on our list of primes, we know we can circle both of those, and we're done. So the prime factorization of 72 is going to be 2 times 2 times 2 times 3 times 3. So we've got 2 times 2 times 2 times 3 times 3. Or if you want to use exponential notation, we have 3 copies of 2, so we could write that as 2 cubed. And we have 2 3s, so we could write that as 3 squared. Again, if all that we're asked to do is find a prime factorization, either of these techniques is going to work. And then I do want to show you just one more other way that we could get a factor tree for 72. So for example, I know from my multiplication tables that 72 is the same as 9 times 8. I know that 9 is the same as 3 times 3, and that 8 is the same as 2 times 4. 3 and 2 are prime, but 4 is not, because 4 is the same as 2 times 2. So here is another factor tree for 72, but it gives us the same answer. We had 3 2s and 2 3s. 3 2s and 2 3s. So again, whichever way you're making your factor tree isn't going to be a problem, as long as each time you're dividing and you're being methodical in your work. So we've got a few questions for you to try on your own now. Determine whether or not each of these is true, so if these are prime factorizations or not. and then use a factor tree to find the prime factorization for each of these numbers here. So chapter 4a was a pretty hefty chapter. We had lots of videos on it, and this one's kind of long. In our next section, they're going to be a little bit shorter, and we're going to be exploring properties of numbers. So we've already checked some divisibility properties, or being prime or not. In the next few videos, we'll start talking about other kinds of properties as well. I hope you have a fantastic day, and I'll see you next time. Bye for now, everybody.